Good evening, friends. Today I have tried to upload video but incapable due to laptop problem. So again I am trying. I don't know I'll be able or not. We are discussing about the dropper length and dropper spacing of INSPAN dropper. It's very easy to find out the spacing of dropper cause the span, the standard span, that means which is divided by 4.5, that is standard span, and which is divided by 9 but not by 4.5. Sorry, which is divided by 4.5 but not by 9. That spacing is somewhat easier. The first dropper is called A dropper, the second B, the third D, the fourth D, E, A, B, C, D, E. Normally we are going up to E. Again it will repeat. So first dropper is spaced at 2.25. It is somewhat fixed. It is somewhat fixed. You cannot change it. But the second dropper, the span which is divisible by 4.5 but not by 9, like 67.5. In that case, the A dropper, the first dropper after the mast, span is formed by two masts. So from each mast towards E, it is spaced 2.25. Then all will be 9 if it is divisible by 4.5 and not by 9. So you can easily design it. But which is divisible by 9, that will be spaced. A dropper is 2.25, then B dropper is 6.75. Then again 9 will repeat, and from other end after mast it is 2.25 and then 6.7, then other all are 9. So this is the system. So you can easily find out the number of droppers and its spacing. It is somewhat easy. Simply you have to remember that which is divisible by 4.5 but not by 9, that spacing will be 2.25 from the true mast, then all will be 9 meter. But which is divisible by 9, that will be said A dropper is 2.25 and next dropper is 6.75. So 6.7, 2.12, it is 9 meter. Both in 9, 9, 18 meter reduced from the span and then divided by 9. Divided by 9 and all dropper will be spaced 9 meter after that. After A and B dropper, all dropper will be spaced 9 meter. So it is not so hard work, you can do it. But the hard work is how to find out the length of the dropper. The length of the dropper we have already seen the calculation. The first dropper, after placing, the catenary will sag somewhat. It is called H. After that B dropper, the sag on catenary is Y1. Y1 after H. From H height, it will be Y1. Then Y2, it will be added. It is the contact or stagger. Due to the placement of dropper almost conductor is horizontal, but some sag will be there due to its weight. So it is Y2. Y2. So the dropper length is incumbent is E, then E minus H minus Y1 plus Y2. Now H, we know the formula B by 2T. B is the spacing of first dropper, T is the tension 1000 kg. P is the weight of OHE, it is 1.6 kg per meter, and multiply it with this span. So the total weight you can find it out. Then C minus C into B. What is C? C is the weight of catenary per meter and B is the first dropper spacing. So you can find it out the H easily. Next is Y1. We have found out the Y1 from parabolic formula. We have already seen that it is ax square plus bx plus c. We have found out the ABC constant and it is coming P minus W. P is the weight of OHE, it is 1.6 kg per meter. P minus W. W, what is W? After placement of first dropper, A dropper, most of the weight of conductor will be transferred to catenary through these two droppers, two A droppers at both ends. Then remaining weight is W. Remaining weight is W. W for 72 meter span is 0.084 per meter. 0.084 per meter. For other span, it will be the span square divided by 72 meter span square into 0.084. So you can easily find out this remaining weight W. Suppose your span is 36 meter, so your W will be 36 square by 72 square into 0.084. So from there you can find out the W. Then X. X is the distance of the dropper from the mast, from one end mast. It may be 2.25, it may be 9 meter, it may be 18 meter, it may be 27 meter. In this way, you put the value of the X, the distance from one mast to the next dropper distance, that is X, minus B. B is fixed 2.25. B is 2.25. So easily you can find out Y1 also. T is the tension 1000 kg. A is the span. If it is 36 meter span, you have to put 36. If it is 45 meter span, you have to put 45. Next is Y2, the contact stagger. Contact stagger is W by 2T. Already we have found out W. W is the remaining weight on contactor after the placement of first dropper. It is 0.084 per 72 meter span, and for other span it is other span square divided by 72 square into 0.084. So you clear the value of the W. Again X minus V. X is the distance of the dropper from one end mast and B is the 2.25. A is the span. Any span 36, 45, 54, any span you put the value for which you want to find out the length of the dropper, you put the value there. X, the distance of the dropper from the mast, one end mast, and B is 2.25. And find out the length of the dropper, it is E minus H minus Y1 plus Y2. All values of this parameter I have given. B is the 2.25, T is the 1000, this is fixed. P is 1.6, it is also fixed per meter. A, span is variable. Span may be 72, 67.5, 63. In this way span will vary. C, catenary weight, it is also fixed. It is 0.604 meter kg per meter. 0.604 kg per meter. Then W I have told you already. W how it is coming. Now 0.084 is for 72 meter span, and for other span square divided by 72 square into 0.084. And x value is first dropper is 2.25, second dropper 9. So in this way you can put the value of the x. In this way I have find out for 72 meter span dropper length in the Excel sheet. You put the calculation in the Excel sheet and find out the dropper length. Dropper length, it is very much required where the incumbent is not 1.4. It will somewhere in wall and structure, under bridge, under tunnel, it is reducing. The incumbency is reducing. Somewhere it is 500 maybe. In the siding and other places, somewhere the situation is like that you have to reduce up to 500. Minimum incumbency you can put up to 300 millimeter. So according to this incumbency, your dropper length will change. But in the workshop, we are not maintaining all this length of dropper when the incumbency will reduce. So keep this chart, keep this calculation, and where some special cases the incumbency will reduce, then you put the value and find out it. Some other cases also there, that is one end is 1.4 and other end is 900. 900 millimeter or 0.9. So incumbency in one mast is 1400, but in other mast is 900. So in that case, what it will be, that can also be found out. What you have to do, 140 minus 900 divided by number of span, number of dropper spacing. How many? So it will give you what will be its changes. Means suppose in E dropper, what you have to do, one end is 1.4, another end is 900, so 1.4 minus 900 is 500. 500 divided by is means how much, to find out the x value, divided it x. So in this portion it will reduce in this ratio, step by step per meter, how much it will reduce, find out that and put the value. I will give you some example later. Today up to this my video is not preparing, I don't know the reason. Again I am trying, let's see. Good luck.